Okay, this is the story with this particular problem. The audio is lost on this video, so I'm going to recreate it as best I can here, so just bear with me. This is homework 9.123, exponential logarithmic functions. I'm going to make an assumption that you've seen the prior video, so this should cover much of the same territory. Hitting start. This is a problem that asks you to use the same base property, which basically is saying that 5 is a common base to both of these numbers. And if you know that 5 is the base on the left, that means that 5 will be also the base on the right in some way. And 125 is a perfect cube. It's 5 to the third power. So you would write 5 to the third power. And if you notice, if you think of the 5s as canceling out, now they have the same base, so they can cancel out. And what you're going to be left with is an equation of n equals 3. And that's your answer. That's what they're looking for here. And these are really easy to do. You just have to remember that if you give you a question like this, there is a common base. You just have to seek it out. So next question. Okay, what have we got here? We've got the same like basis property to solve the equation. This is exactly like the other one, except that there's a coefficient of 5 you have to deal with here. All you have to do is make sure that you divide anything that's not a base and exponent on the left hand side. So you've got that 5 in front of the parentheses that has to be divided out from 1215. So do that first. And if you do that first, you should be okay. You're going to simplify down to 3 to the x power equals 243. Okay, and 243, you can make a clear assumption that 243 will have a base of 3. It can be rewritten with a base of 3. And once you know that, you just have to seek it out. And that's really the worst of this problem. 3 to the x ends up being 3 to the power of, I think it's going to be 5. I think it's going to be 5. 3 to the x power, 3 times 3 times 3 times 3 is, times 3 is 243. So you're going to write x equals 5. And again, easy. So you just click it. You're done. You move on to the next one. And the next one, let's see what that one looks like. Okay, now we've again got the like basis property. The only problem now is that it's a fraction. But again, you're being told that 1/2 can be raised to some power in such a way that you're actually going to, at some point, achieve 128. So that's the only real problem you have again. 2 to the negative 1 power. We have to rewrite that, by the way. 2 to the negative 1 to the x power is equal to 2 to the something power, and I think it's going to be 7. So we're going to put 7 there, and we have to simplify the left-hand side by multiplying the inside with the outside. So negative x equals 7 means that x is equal to negative 7. Okay, so again, do that reciprocating, get that negative exponent thing on the second line, and you should be okay. You may want to practice with a different one, but I think it's enough. For the next problem, this is again like bases, and again as before, you're definitely going to rewrite the 1 over 1000 in a non-fraction way, and that would turn that into 1000 to the negative 1 power. And now if you look at the left, it's 10,000. That's 10 to the 4th power equaling n, and 1000 is 10 to the 3rd power raised to the negative 1 power. Simplifying both sides, you're going to get 10 to the 4n is equal to 10 to the negative 3. That tells you that 4n is equal to negative 3. Divide both sides by 4, you get negative 3 over 4. Whether it'll take negative 0.75 is a question, but you should feel free to try both ways because they're not really wrong. It may tell you it doesn't like the format or something, some kind of warning like that, but you should be okay. So we're going to type in negative 3 over 4. Okay, we're fine. We got that right. And would it take the other one? Let's see. Nope. Let's see. 0.75. No, it wants the fraction. It actually says not a valid fraction. So get that whole talk out of your mind. And again, laying weight to my opinion that fractions are better than decimals, generally speaking, most of the time. Number 5. Okay, we're more than halfway there. Okay, the common base is already 2. 2 to the x plus 9 is equal to 2 to the 7x plus 7. And that's going to be really easy, except you have to, group like terms. But x plus 9 will end up having to equal 7x plus 7. I'm going to take the x and bring it over. I'm going to take the 7 and bring it over. That'll give me 6x, and that'll give me 2. And I'm going to divide both sides by the 6, and I'm going to get x is equal to 1/3, not 2 over 6. You must reduce. Remember, you should always get into the habit of reducing wherever possible. You should get 1/3. Again, not too big of a deal. Number 6, let's see. Okay. 2 to the x power is equal to 38. Now, this is a slightly more complicated problem. You're going to need a calculator, simply because we know that 2 to the x power never actually hits 38 with an integer. The closest you get is 2 to the 5th power being 32, and 2 to the 6th power being 64. There's no 2 to the x power that's going to give you 38, which is our problem. Okay, because 2 to the first is 2, 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, and as I said before, 2 to the 5th is the closest we get with 32, and 2 to the 6th is the next value up over 64. So you know that it's somewhere between 5 and 6. It's probably closer to 5 than 6, so it's going to be something like 5.0 something when we find it out, but it's got to be between the two values, and that just makes sense. You can kind of make an estimate there. So your value is going to have somewhere between 5 and 6. You do need a calculator, which is still better than what we had to do back in the old days. We had to use a table in the back of a textbook and search it up by column and by row. It was a real pain. I didn't like it. And what you do is you take the logarithm of both sides. Because x is an exponent, we need to use the power rule to bring the x down so that we can calculate that value. X log 2 equals log 38. Solving for the x will give you log of 38 divided by the log of 2. So make sure you do it exactly that. Log of 38 divided by log of 2. Not log of 38 over 2. Not the same thing. Make sure you don't make that error. You're going to be log of 38 divided by the log of 2. And that's going to be your answer exactly. You don't have to worry about the values because that's the exact value. Again, fractions are better. And we got it right just by doing that. If you had done it, you would have figured out it's about 5 point something, but it's not really necessary for us. This is the same kind of problem, except we're not using base 10. We're using natural base of e. But the same idea applies, that the exponent is on the x is in the exponent. It's unattainable unless we bring it down to earth by using logarithm, or in this case, natural logarithm, or ln. So we need to remember not to use log in this case. We have to use the ln in this case, and that's on your calculator as well. You should find it. It's usually paired off with the E key on your calculator, assuming you have a scientific calculator. So just look for that letter and understand you have to apply the ln. ln of e to the 2x plus 1. Again, you do both sides, ln e of 39. Now you can use the power rule to bring that down. 2x plus 1 ln of e is equal to the ln of 39. Now, one thing that's really nice about ln of e is that it cancels out. It just disappears. So it's really easy. You just knock it out, and you continue to solve the rest of it because they do become much easier after that. Once you get that ln of e, automatically remember to cancel out. The equivalent of that is log base 10 of 10, which is 1. The log base e of e is 1. It's the same thing. You end up getting 2x plus 1 is equal to ln of 39, and then you have to subtract 1 to get the 2x by itself. So it's ln of 39 minus the 1. The final step is to divide by 2. So that whole expression is the correct answer. And it's asking you to either write it in terms of logs, which I think is better, but if you do the entire calculation, make sure you got to take it to 4 decimal places and round it off if you take it there. Okay, so this is the answer. I'm not going to do the 4 decimal places. I think it's easier just to do this. So in here, again, fractions. You need to create a fraction and do ln of parentheses 39, and then close parentheses, and then minus 1 over 2. That's the exact answer, which, again, fractions are superior. It's just easier. Okay, if we can get over the mental block that you may have of fractions being evil, they're not evil. They are your friend. Okay, number 8. Okay, same kind of a problem as before, But just like with the other problem that we had before, the second one, I think, we have a coefficient we have to get rid of before we can do any work. In this case, that coefficient is 12. So 12 e to the x is equal to 15. And we can divide both sides by 12, and you're going to get 5 over 4. If you reduce, remember to reduce, now you can do the ln of e to the x equals the ln of 5 over 4. And you can use the power rule at this point. Okay, it's a quotient. Oh, right, the quotient rule. I forgot to mention that. The quotient rule is ln of 5 minus ln of 4. You might need it. You might be able to leave it that way. I just kind of get really fussy about this. I like to make sure that I have all my ducks lined up. So you got to get x ln of e is equal to the ln of 5 minus ln of 4, or ln of 5/4, ln of 1.25. So x is really easy in this case. It's simply that value. X is equal to the ln of 5 minus the ln of 4 over, no, that's it. That's ln of 5 minus ln of 4, that's it. Or it might have worked out that ln of 5 over 4 might work as well. Not sure. It should, but, you know, it's easier this way too. Not a huge issue. Ln of 5/4, will it take it? It did take it. It didn't have to do that quotient rule. We could have left it that way. That's good to know. Would it have taken the other way? I think it will. Let's see. Ln of 5 minus the ln of 4. And will it take it? And it did take it. It took it either way because there's the same answer. It's just in different forms. So who cares what form the answer takes as long as the answer itself is correct. I hope this is helping so far. Where are we now? Number 8. That's the last one, actually. We're done. So we can just finish off. We have a perfect 8 out of 8 on this problem. And with the decimal, you don't want to deal with the decimal. No, hit the wrong key. My bad. We're going to hit done and get out of here. And we are finished with this particular unit. I hope this helped. See ya.